Hi, this is Mark Kemper with EMS. In this video we're going to demonstrate the Creaform GoSCAN, a 3D scanner. This is the model 50 and there's also a model 20. The 50 has a bigger scan window of about 12 inches. The 20 has a smaller window for smaller parts of about 4 inches. But basically this is a projected light, white light scanner. And you can see it's very portable. It's basically one USB cable that plugs into a computer. So you can take it out on the shop floor. You can take it just about anywhere. It's got a nice small travel case. It's easy to carry it onto an airplane and go scan somewhere. And today's video we're going to scan an application of shoe lasts. So shoe lasts are used in the manufacturing of shoes. And if you wanted to basically bring this in digitally to be able to make copies of it or make changes to it and then manufacture the last, you could do that. So how this scanner works is it has a projector here and then a sensor here and a sensor here. So it's an LED projector light, and then over here is a color camera. So what it does is it projects out a pattern of light, and as that pattern distorts on the shape of the part, these sensors pick up that distortion and figure out the 3D shape. And then the color camera basically is taking color images and associating it to the scan data, okay, so as you move along. And then finally you've got some LED lights here. Those will light up these little round targets. Now we're not really using them for this application because our part has enough shape. But if you were scanning something very flat, the way the scanner works is it's basically aligning all those scans, and it's taking many scans a second. It's aligning them by looking at the geometry. So as you scan along, it aligns it. And as long as there's enough shape to what you're scanning, it works perfectly fine. If you had something very flat like this table, it's very difficult to try to line up, a flat scan to a flat scan. So if you put a few targets on, the unique pattern of those targets, it can align those scans by looking at those targets. So if you need them, you can throw them on. If you don't need them, you don't use them. But the way the scanner works, it's quite simple. You hold the part about 15 inches away, and you just start scanning. It's all line of sight. So for example, if I want to get up underneath here, I just kind of rotate the scanner down, and you can see I've just got a little lazy Susan with a dowel kind of holding this in place, and a little vise. Now I'm going to roll up here. So just a really easy and quick fixturing setup, and you can see here now I'm filling in on the bottom of the last. Okay? And if it gets lost, if it can't align itself, you just go back to a known position and keep going. And you can see now I'm kind of getting the back of the last here. Okay. And you can start and scan at any time. If you see an area you've missed, you can just go back and get it. Let's go get the bottom of the last here. And then that's about it. So we're pretty much done. So 15, 20, maybe 30 seconds, you could scan a last. So very easy. Could do it out on the shop floor. You don't need an engineer to do this. Let's go ahead and hit stop scan, and I'll explain what that's doing. So once we're done scanning, the VX Element software that comes with it is going to take all that raw points, because we've collected a lot of overlapping data. It's going to clean it all up for us and make a nice polygon file. Polygon file is like an STL file, a triangulated mesh. So it takes those raw points and converts it into a nice polygon model for us. Okay? So we can output this now as an STL file if we don't care about color, or if we want color, we could output it as a OBJ, a vermal, ply, and if you look closely here, you can see the actual wood grain pattern on the actual last. So if color is important to you, you can output it. If it's not, you don't have to worry about it. So that's really it. If I wanted to save it, I could do that. Let's just go ahead and reset it. And again, I'll just show you the flexibility of the scanner. I'm just going to hold this thing in my hand and basically do the same thing. So again, hold it about 15 inches away. There's a little meter on the left there. And just kind of move around. And again, it's all line of sight. The more perpendicular you are as you scan, the better. You're just going to get the best data. And being handheld, it just makes it very easy to do that. Okay. And just for fun here, I'll go ahead and scan up my arm so you can actually see the color data. Okay. Okay, so let's go ahead and hit stop scan and let that So however you want to fixture it, it really doesn't matter. As long as you've got a clear view to the piece, you could just set it and scan it and flip it over and scan it. Putting it on a dowel like this just kind of separates it from the table or other data. It just makes it very easy to edit. But again, however you want to fixture it up to scan it. So again, you can see here the scan data, and of course you can see my hand right there. So that gives you an idea of the color. But very good quality. Once I'm done scanning it and processing it, I can crank it down. I can reprocess the data to different resolutions, and then once again I'm ready, I'll output either an STL, OBJ, Vermal, different formats depending on what our needs are. So next step is I'll take it in some other software. The VX Elements does a good job of just collecting, but we may want to work with some other software, and we're going to show that next.
Okay, so here we are now. We are using, for this demo, Geomagic Design X, but you could also use Geomagic Wrap and some other software to do what we're doing here. But you can see the data. This is right out of the GoSCAN scanner, so very clean data. And there's a whole bunch of tools in Design X if you want to fill holes and smooth, but we really don't need to do anything. We've got good quality data right out of the scanner. So what I'm going to do is kind of get into a top view here, rotate it a little bit, and then what I want to do is get rid of the dowel that we had put on our part. So the first thing I'm going to do is just kind of go into top view and select it, and then what I want to do here is, because it's selected all the way through the part, I want to remove that down there in the bottom of the part, so we just have the dowel, and we'll go ahead and just remove that. So we've just got a hole left here, which now we're going to go into our hole filling command, and we'll just do a flat hole, and we'll pick that boundary and hit OK. So there's no more holes. So you can see we're pretty much done at this point. So if all we want to do is output a STL file, we can come right under here and hit export and save an STL. Just to show you some of the nice tools, there is a smoothing tool, so you can smooth things out. You can fill holes, you can do some things. But again, we've got such nice data quality right out of the GoSCAN scanner in the VX Elements software. We really don't need to do anything. So we're ready to go if all we need polygon data, and that could be done for 3D printing, and even some CNC operations can work straight off of the polygon data. Okay, the next step is we want to run a command called auto surface, and what we're going to do here is I'm just going to make a few adjustments. We're going to do an organic patch. We'll let it estimate the amount. Take the next step here. And the reason we want to run this auto surface command is what it's going to do. It's going to basically generate, as you see here, kind of a quilted patch of surfaces. Because this is very organic shape, we really can't feature base this or sketch drive this model. So we're going to basically let the software just figure out a kind of a network patch of surfaces based on the shape. And essentially what it's done here is auto surface this so that this is now a surfaced CAD model. So now when we export, we can actually export an IGES step or parasolid model, because you can't, if you look back at the polygon data, and let's just go turn on the edges and zoom in here, it's not it's just triangles. It's not mathematical surfaces. So polygon data can't be output as an IGES or step file, and a lot of CAD systems need an IGES or step file. So what it's done is it's created four-sided NURBS surfaces, and the pattern of them is calculated by the software, and it's basically based on the organic shape and some settings I set. But you can see it's a nice perfect fit to the scan data, and now I have a CAD model in IGES or step or parasolid format, and every CAD system can read this in. Machining software can calculate toolpath and other things now off of this CAD model. So very quick way to scan it, clean up the polygon model, and then auto surface it. So this whole process of scanning the last, cleaning it, and outputting a file for machining or other downstream CAD applications literally took me a couple of minutes.